Okay, today we're going to talk about 3 ways to represent models of atoms and ions using either the Bohr model, the Lewis dot model, or the dot cross model, which is commonly used in the ACE book. So let's take a look at the Bohr model first. We've seen the Bohr model before, so this one should be a review for you. But I'm going to do it comparing the Bohr model of the atom versus the Bohr model of the ion, which is what we know now. So for potassium, the atom, we have our nucleus here in the center. Potassium has 39 protons, and it has, whoa, my bad. Looking at a different book, which means that I am looking at it's done in a different format. So let me start that over. Potassium has 19 protons, and it has a mass of 39, which means that it has 20 neutrons. Potassium is in period number 4. We're going to draw 4 rings there. It has 1 electron out there, 2, 8, and 8 electrons there. So that's the Bohr model of potassium that we've seen before. The ion, the only thing that changes in the ion is that with the potassium ion, we have now lost that 1 valence electron in that 4th shell, and so we simply write it as 288. Because it has lost an electron and has taken on a charge, we write a bracket around the picture and put a positive 1 in the upper right-hand corner to show that it is now an ion. Let's take a look at the iodine atom versus the ion. Iodine has an atomic number of 53. Its number of neutrons 127 minus 53. So I don't have my calculator with me. That's 50, 77 minus 3 is 74, I believe. If I have these numbers off, I apologize. I'm doing this quickly in my head at night. Iodine is in period 1, 2, 3, 4, 5. So it's going to have 1, 2, 3, 4, 5 shells. It is in group 7, so it has 7 electrons there, 2, 8, 18, and then to make it 53, that's 10, 28, 35, 45, 55. So this shell right here has 18 like that. Okay. The ion has 53 positives, 74 neutrons. That doesn't change. But what does change is that that 5th shell is going to pick up 1 electron. So its picture looks like this. Take a look at oxygen. Oxygen has an oxidation, or has a proton of 8. It has 8 neutrons. It is in period 2, group 6. So its configuration for the neutral atom is 2, 6. For the ion, it is going to be 2 and 8. This shell right here picks up 2 electrons, and then we write it as 2 minus. Magnesium. So magnesium, we have 12 protons and 12 neutrons. It has 1, 2, 3 rings. It's in period or group 2. So this is 2, 8, and 2. The ion, 12 protons, 12 neutrons, and it loses that 3rd ring and then takes on a positive 2 charge. We are going to skip these problems. We will do those in class. And then we're going to take a look at the next type of diagram, which is called a Lewis dot diagram. Lewis dot diagrams are so simple. Follow these steps drawing these diagrams. Let's take a look at the sodium atom. When you draw a Lewis dot diagram, you are only drawing dots to represent the valence electrons of that atom. You're not drawing energy levels, you're not drawing all the electrons, you are just showing the valence electrons, which can simply be found by looking at the group number the element is in. So you draw your symbol on your page. Step 2, figure out what group it's in. Sodium is in group 1. Determine the number of valence electrons in that group. It corresponds to the group number. So group 1 has 1 valence electron. And then draw the number of valence electrons around the symbol. Start on the right-hand side of the symbol and fill 1 electron counterclockwise. The max you will have around the symbol will be 2 on each side. So because sodium has 1 valence electron, it will have 1 dot around it. If you have more than 1 electron, you have to fill it in on one of the sides before you start to double up. What you wouldn't do is you wouldn't draw the 2 electrons next to each other like this. The reason being is that electrons are negative particles. They repel each other, so they will never be that close together if they have the option of spreading out. So if there was 4, the 4 would go here, and if there was 5, then you would start to double up. But sodium just has 1 dot. Let's take a look at oxygen. Oxygen is in group 6. It has 6 valence electrons, so it will have 1, 2, 3, 4, 5, and 6. Notice how I went around the 4 corners first before I started to double them up. Tin. Tin is in group 4. It has 4 valence electrons, and so I would draw it with 4 dots. Bromine. Bromine is in group 7. It has 7 valence electrons, so it will have a Lewis dot diagram with 7 dots around it. Let's take a look at how to draw the potassium atom versus the potassium ion. So the potassium atom is simply 1 dot like that. For the ion, what you do is you draw it without that dot, and then you show the new inside shell, which has 8 valence electrons around it, and then put a bracket saying +1. So what this is showing is the new, after the potassium has lost its electrons, it's showing the new outer shell with 8. Whoa, shoot. Sometimes I press the wrong button and it brings me all the way to the bottom of the slides. So let me start again. All right, the iodine atom. Iodine is in group 7, so it has 1, 2, 3, 4, 5, 6, 7 dots. It is going to pick up an electron in this spot right here. And so you draw it with that 1 electron there with a -1 on the outside of the bracket. So in other words, the Lewis dot model for the ion, whether it's a positive or negative ion, you always draw the 8 dots and then either the positive or minus charge around the brackets in the upper right-hand corner. For the oxygen atom, we have 1, 2, 3, 4, 5, and 6. It is going to pick up 2 electrons in those 2 spots. So 1, 2, 3, 4, 5, 6, 7, 8. And then it will have a 2- charge. For magnesium, magnesium is in group 2, so it has 2 valence electrons. When it loses those 2, its new inside shell will have the 8 of stable electrons it needs, and it becomes 2 positive. We will do these pictures in class together. Let's take a look at the last model, which is called the dot cross model. The dot cross model is commonly used by the ACE program. It uses dots and crosses to represent valence electrons and show the movement of electrons when they get lost, gained, or shared. It is very similar to the dot model, except you draw different symbols for different elements, electrons, so that you can see where those electrons came from when they turn into ions. So for example, the potassium atom dot model looks like this with a positive, with a single valence electron. The ion you're going to represent very similarly with 8 valence electrons around it and a positive one on the outside. And in some cases, I think your worksheet actually wants you to do it this way. I think your worksheet actually shows an empty inside shell and positive one here. So this represents the empty old outer shell. For iodine, iodine has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. For the ion, it's going to be drawn the same way, except in this spot right here, you're going to use an X to represent that that electron came from somebody else. And then you put the -1 in the corner. Oxygen. So oxygen has 6 valence electrons. These two spots are unpaired. So in the ion, you represent those two spots being filled by electrons of another symbol to represent that those electrons came from something else. Magnesium. So magnesium has 2 valence electrons. In the dot cross model, you represent it with a empty ring. We will do these in class, and that is where we will end for day 2.